Now that we've deployed the job, we can actually trigger it with different hyperparameters and get the results. So I'll go to the job details page. From here, I'll click on run job, and then I can set these parameters. So let me set it to 64, 64, and batch size of 256. And then I hit run. So the job is scheduled. Meanwhile, I've already run this a couple of times. So you can see that I've run it with different hyperparameters. In this case, 64, 32, 512 for convolutional filter 1, convolutional filters 2, and batch size. Here the values are 32, 64, and 256. And this is 16, 16, and 128. So I'm running this job multiple times for different hyperparameters. And for each of these job, we actually create a run. You can see the loss, the validation loss, the accuracy, validation accuracy. You can see the hyperparameters that I've set here as well. And you can see how the loss changed across epochs. You can see how the validation loss changed across epochs. So all this is available across all of this is available for each run. And you can see the model that was created in that run. So every time this script was run, a model was getting created. So you can see the model as well. Let's wait for this run to finish, and after that we'll compare between the models created in these different runs and decide which model to use for our deployment. While running the job, you can take a look at the job logs here. So these are the logs that is generated by the job that is currently running. You can see the shape of the model. You can see uh, the total number of parameters, trainable parameters. This is the model summary that you can see here. After that, you can see each epoch as they are getting completed. You can see the accuracy and the validation accuracy after each epoch is completed. For example, after the first epoch, you can see the accuracy is 0.96 and validation accuracy is 0.98, and you can see that for each epoch. And now, right now, we're running the fifth epoch out of five. So immediately after this epoch, we should be able to save the model. The code should save the model, and which should be available for use in the deployment flow. You can also see the metrics meanwhile, which is the CPU usage, memory usage, network usage, etc. for each of the pods. So you can see that the job has transitioned from running to finished, which means our current job is also complete. The model should be saved in the model registry. So you should be able to see that if you go to the job details, you can see the overview, you can see the metrics, you can see the hyperparameters, and if you go to the model section, you should be able to see model as well. We can also see this from the ML repo that we created. We go back to our ML repo tab, go to the current ML repo, which is MNest classification, and you can see that there are four runs corresponding to the four. There are four different runs corresponding to the four times we trigger the job. This test run was created from the notebook, but the other four were created by triggering the job on TrueFoundry. So here, what I can do is I can compare the values between them. So in this case, I'll sort them in the descending order of validation accuracy, and I can see that this particular run corresponding to batch size of 256 and epoch 5 epochs, this one produces the best result. So I open this, and then I go to the models. I can see that the third run, the version 3 of the model, has the best performance. And in the coming video, we'll be using this model to deploy a UI wherein you can upload an MNest image and get the classification.